This is an atom. They are in everything. The structure of one of these atoms is very simple but important. If we look at the Bohr planetary model named after Niels Bohr, you will see that inside the rings are a cluster of protons and neutrons in something called a nucleus. This nucleus contains both protons and neutrons and is positively charged because the proton charge is 1 and the neutron charge is 0. Also, it is incredibly small. It is only 1 times 10 to the minus 14 metres. The protons are 0.84 femtometers and the nucleons are only 1 femtometer. Orbiting the nucleus in shells or energy levels are the electrons. These are tiny and are the smallest subatomic particle in an atom. The energy levels are where reactions happen, specifically in the valence shell or the outer shell. The electron has a charge of -1, and since there are the same amount of protons and electrons in an atom, as long as it is not a cation or an anion, the charge of the atom is neutral overall. In terms of mass, the relative mass of a proton is 1, a neutron is also 1, and an electron is 1 over 1837. Each atom has a unique number of protons, and that determines the element it is. Therefore, isotopes, which have more neutrons in the nucleus, doesn't change the element it is, as the proton number doesn't change. In the periodic table of elements, the elements are arranged in an order of their atomic number, which is the number of protons and electrons in an atom. Calcium has an atomic number of 20, so therefore contains 20 protons and electrons. In the periodic table, each element has a symbol. The way of writing this symbol is very important. The first letter is always a capital letter, and the second letter is always a lowercase letter. Mercury has the symbol Hg, and the H is capitalised, and the G is lowercase. There is also a relative atomic mass in the periodic table. This is the bigger number, and is the average mass of all the isotopes. To get the number of neutrons in the nucleus, you need to take away the atomic number from the relative atomic mass. Now we know how to find how many subatomic particles there are in each element. Let's try it. Gold has an atomic number of 79 and a relative atomic mass of 197, so therefore contains 79 protons, 79 electrons, and 118 neutrons. Now we can do that. We can move on to electronic configurations. An electronic configuration is a diagram of the shells in an atom, and it shows you where each electron is placed. At this level, you just need to know that the first shell can hold a maximum of 2 electrons, and all subsequent shells can hold 8 electrons. You only need to know the first 20 elements at this stage. For example, neon has an atomic number of 10. In the first shell there must be 2 electrons, and in the second shell there must be 8 electrons. This element is now stable, since its outer shell is fully occupied. Electrons come in pairs. For neon, the electronic notation would be 2-8. A diatomic particle is a molecule that needs to be in a pair as a pure element. This does not affect the compounds. The 7 diatomic particles are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. There is one triatomic particle, which is ozone. Reactions occur when electrons move from one valence shell to another. There are 2 types of bonding: ionic, which is a metal reacting with a non-metal, and covalent, which is a non-metal reacting with a non-metal. In an ionic bond, electrons move from the metal to the non-metal, and in a covalent bond, electrons are shared. To represent this, we use something called a dot and cross diagram. This diagram shows people how the electrons move to form new compounds. For an ionic bond, you draw the electronic configuration of the metal on the left and the electronic configuration of the non-metal on the right. The electrons on the left should be crossed, and the ones on the right should be dots. Once you have done that, you need to aim to make both atoms stable. And to do that, you need to give them a full outer shell. For this example, sodium gives an electron to chlorine, and both atoms are now stable. For a covalent bond, the valence shells overlap, and the electrons that need to be shared are put in the middle. In this example, both hydrogens put their electron in the middle, so now they each have 2 electrons. I hope you found this video useful. If you did, please like and subscribe for future educational content.